Hey guys, today we're going to learn how to add and subtract rational functions. But first, let's review how to add and subtract fractions, since the same process that we use to add and subtract fractions is the same process as when we are adding and subtracting rational functions. So here we have 1/2 plus 3/8. In order for me to be able to add fractions, I need the least common denominator, also known as the LCD. For here, between 2 and 8, the least common denominator would be 8. So that means that we want both of these denominators to be 8. So we'll start with the first fraction, and we're going to need to rewrite it so that it has a denominator of 8. In order for this 2 to become an 8, we need to multiply it by 4, meaning that I also need to multiply the top by 4, plus then 3/8 is already has a denominator of 8, so we can leave it. Now let's rewrite this. 1 times 4 is 4 over 8 plus 3/8. When we are adding fractions, what we do is we add the numerators, but the denominator stays the same. So essentially, this is the same thing as saying 4 plus 3 all over 8, since the denominator is going to stay. 4 plus 3 is 7. So we get a final answer of 7 over 8. Now let's try subtracting. We have here 2 over 4 minus 3 over 5. If we're trying to figure out the LCD here, if you're not sure what would be the least common denominator, you can always take your two numbers and multiply them together. 4 times 5 is 20. So that's going to be my LCD. So I want to rewrite both of these fractions so that it has a denominator of 20. Let's start with 2 over 4. In order to turn this 4 into a 20, I would need to multiply it by 5. And whatever you do to the denominator, you must do to the numerator. So I also need to multiply the numerator by 5. Now moving on to 3/5. In order to turn this 5 into a 20, I would need to multiply it by 4. And the same goes to the numerator. So now let's rewrite this. This is now 10 over 20 minus 12 over 20, which we can put it as one fraction as 10 minus 12 over 20. And 10 minus 12 is negative 2 over 20. Now this is the answer, but it can be simplified. Both the numerator and the denominator can be simplified by 2, meaning I would divide the numerator by 2 and divide the denominator by 2, which gives me a final answer of negative 1 over 10. And this will be my answer. Now let's examine some rational functions and how to determine the LCD. So in these questions here, we're not going to add or subtract quite yet. We're just going to practice how to figure out exactly what is the LCD. Now, in order to find the LCD, I have here some steps here for you that you can follow. First, you would have to factor each denominator completely. So let's start with that first step. In the first rational function, my denominator is 3x minus 15. If I factor that, I can take out a 3, which will give me 3 times x minus 5. For the second rational function, in the denominator, we have 4x plus 28. We can factor out a 4, and that will give me x plus 7. So now to get the LCD, basically we're going to write any repeated factors as powers, but we don't have any repeating factors in either one, so we don't need to worry about that step. For 3, we're going to list the different factors. That's basically what I have here. We have 3, we have x minus 5, we have 4, and we have x plus 7. Now, in order to figure out the LCD, all we do is we put these factors together, meaning multiply them. See, if we go back here to this example, what did we do to find this LCD? I took the 4 and the 5 and I multiplied them to give me 20. So here I'm going to do exactly that. I take the 3 and the 4 and I multiply it, which is 12, And then the x minus 5 and x plus 7, I also multiply them, but you're not going to actually multiply them. You're just going to write them next to each other. This essentially means that everything is being multiplied. But like I said, you don't actually multiply them. We keep it like this, factored. So this is going to be the LCD. Let's try that with this one. Here we have x squared minus 11x plus 24. This can be factored to x minus 8, x minus 3. Since negative 8 times negative 3 is 24, and negative 8 plus negative 3 is negative 11. Over here, we have x squared minus 6x plus 9. This can be factored to x minus 3 times x minus 3. Since negative 3 times negative 3 is positive 9, and negative 3 plus negative 3 is negative 6. Now this is like here in step 2. Write any repeated factors as powers. These are repeating factors. So I would write this as x minus 3 squared, because there's 2 of them. If there were 3, then it would be cubed. If there were 4, it would be to the 4th, etc. Now to get the LCD, we're going to put all of the unique factors together. We have this x minus 8. Then we also have the x minus 3. In this rational function, it's x minus 3 as well, but it's squared. So if you ever have the same factor in both of the rational functions, you only write it once, and if one of them has a higher power, you take the one with the higher power. So that would be my LCD for this example. Now let's actually practice adding and subtracting. Here we have x plus 6 over 8x minus 24 plus 2 over x squared minus 5x plus 6. First, we need to factor each term and find the LCD. So I'm going to factor all of these denominators. Here I can take out an 8 and it would give me x minus 3. This can be factored to x minus 3, x plus 2. Since negative 3 times 2, x minus 2. Negative 3 times negative 2 is positive 6, and negative 3 plus negative 2 is negative 5. So now for my LCD, we put all of the unique factors together. We have an 8, we have an x minus 3, we have this x minus 3. It does not have a higher power, so we don't need to write it twice, we keep it. And then we have the x minus 2. So this is my LCD. Now we need to actually rewrite these fractions with the LCD. So we'll start off with the first one. We have x plus 6, and when you rewrite this, use the factored version of the denominator, which is 8 times x minus 3. Now we need to see, what do I need to multiply the denominator by in order for it to be the same as the LCD? I have the 8, I have the x minus 3. What I'm missing is the x minus 2. So I'm going to multiply this by x minus 2 and multiply the numerator also by x minus 2. Plus, now we're going to move on to the second fraction. We have the 2 over x minus 3, x minus 2. I need to figure out what do I need to multiply this denominator so it's the same as the LCD. Basically, you're looking for what factors are missing, and that's what you would multiply. Here in this denominator, it's the same as the LCD, except we're missing the 8. So I would multiply by 8. That means that I would also have to multiply the numerator by 8. Once we've done all of the multiplication, what we're going to do now is write this as one fraction. We have here in this numerator x plus 6 times x minus 2. Plus, we have 2 times 8, which is 16. And now all of this is going to be over the LCD since they both now have the same denominator, which is 8 times x minus 3 times x minus 2. Now, for the numerator, you're going to distribute everything and combine like terms. But for the denominator, you don't have to. Just leave it factored. It's a little bit less work for you to do, and yeah, you don't have to. So here we're going to distribute this x plus 6 to the x minus 2, which would give me x squared minus 2x plus 6x minus 12. And then we can't forget about the plus 16. And again, everything is over 8, x minus 3, x minus 2. Now we combine like terms. In the numerator, we have x squared. Then we have negative 2x plus 6x, which is 4x. And then negative 12 plus 16 is plus 4. And everything is over 8 times x minus 3 times x minus 2. And this would be my final answer. Let's look at this one over here where we're subtracting. We have 3x over x squared plus 9x plus 20 minus 5 over 2x plus 8. Let's factor everything. Here in this denominator, it can be factored to x plus 4, x plus 5. Since 4 times 5 is 20, and 4 plus 5 is 9. Now here, 2x plus 8, both of these terms have a 2 in common. So we're going to factor out the 2, and we get x plus 4. Now to determine the LCD. We have this x plus 4 and this x plus 5. Then we have this 2 and x plus 4. But x plus 4 is already part of my LCD, so I don't need to write it again. So this is my LCD. Now let's work on subtracting. We have here 3x over, remember that we're using the factored version of the denominators, x plus 4, x plus 5. And the reason why we use the factored version is because then we can look at the LCD and see what are my missing factors. Since I have x plus 4 and x plus 5 already, what we're missing is the 2. So I'm going to multiply the denominator by 2 and the numerator by 2. Minus, here we have 5 over 2 times x plus 4. If we look at the LCD, we have the 2, we have the x plus 4, we're missing the x plus 5. So that means that I have to multiply the denominator by x plus 5, as well as the numerator. Now let's write this as one fraction, since everything has the least common denominator. So here we have 3x times 2, which is 6x, minus, then we have 5 times x plus 5. And everything is over the LCD, which is 2, x plus 4, x plus 5. Now we're going to work on simplifying this numerator. Now I put here in red, subtracting rational expressions follows the same process as adding rational expressions, except you must remember to distribute the negative. So we have, this is negative 5. So I am going to distribute negative 5 to the x plus 5. And that would give me 6x minus 5x minus 25 over 2 x plus 4 x plus 5. And now, of course, in the numerator, you want to make sure that you combine like terms, which we only have to combine the 6x and the negative 5x, which gives you x minus 25 all over 4 times x plus 4 times x plus 5. And this would be my answer. Let's try a couple more. we have here x minus 3 over x squared plus 4x plus 4 plus x plus 1 over x squared plus 6x plus 8. So first we need to factor. Here we can factor this to x plus 2 times x plus 2, since 2 times 2 is 4 and 2 plus 2 is 4, which x plus 2 is the same thing as saying x plus 2 squared, because there's two of them. Then here we have x squared plus 6x plus 8. This can be factored to x plus 2 times x plus 4. So now we're going to write out the LCD. If you notice here, we have x plus 2 squared and x plus 2. They are the same factor, but when you're writing the LCD, you write the one that has the higher exponent, which this one is squared, so I'm going to use x plus 2 squared. Then I have the x plus 4. This would be my LCD. Now let's get ready to rewrite these fractions so that we can add. Remembering that we're going to use the factored version, and I'm going to use this one here, the x plus 2 squared. So we have x minus 3 over x plus 2 squared. And I'm going to multiply by the missing factor of my LCD. We have the x plus 2 squared. We're missing the x plus 4. So I'm going to multiply by x plus 4. Plus. Now moving on to the next one. We have x plus 1 over x plus 2, x plus 4. When we look at the LCD, we have the two factors, but this is x plus 2 squared. So that means that I would have to multiply by another x plus 2 so that this would be squared. Now that we have gotten that all worked out, we can now put these together as one fraction. So we have here in this numerator the x minus 3 times x plus 4 plus x plus 1 times x plus 2. And everything is now over the LCD. Excuse the plane. Which is x plus 2 squared times x plus 4. Now we have to just work out the numerator. So we're going to distribute both of these factors as well as these here. So when we multiply x minus 3 with x plus 4, we get x squared plus 4x minus 3x minus 12. Plus, now we're going to distribute these factors. X squared plus 2x plus x plus 2. And everything is over the LCD. Our final step is now to combine like terms for the numerator. So we have this x squared and this other x squared, which is 2x squared. Then we have 4x minus 3x, which is x, plus 2x, which is 3x, plus x, which is 4x. And finally, negative 12 plus 2 is negative 10. And everything is over x plus 2 squared times x plus 4. And this would be my final answer. Last one here. We have x plus 2 over x squared minus 9 minus x minus 1 over 4x plus 12. I can factor this denominator. This is a difference of squares. So it would be x plus 3, x minus 3. Since the square root of x is x, the square root of 9 is 3, and you make one factor positive and the other negative. Here, for x plus 12, both of these terms can be divided by 4, so I'm going to take out a 4, and I would get x plus 3. So my LCD, We have this x plus 3, x minus 3. We have this 4, and then x plus 3, which is already a factor. Remember that you only square if one of the factors in one of the rational exponents was originally squared. Like here, this one was squared, therefore my LCD, it's squared. But here, these are not squared, so you just take it once. Now let's rewrite both of these rational expressions using the LCD. So we have this x plus 2 over x plus 3, x minus 3. If I look at my LCD, I am missing a 4. So I'm going to multiply the denominator by 4 and the numerator by 4. Minus, we have x minus 1 over 4 times x plus 3. If I look at my LCD, I am missing the x minus 3. So that means I need to multiply everything by x minus 3. Now we're ready to write this as one fraction. In this numerator, we have the 4 times x plus 2 minus x minus 1 times x minus 3. And everything is over the LCD. So 4 times x plus 3 times x minus 3. Now we're going to distribute everything. Keep in mind here that this is a subtraction problem. So when I distribute this, I'm going to keep it in parentheses so I don't forget to distribute the negative after. So first, when I distribute the 4, I get 4x plus 8 minus, now I'm going to distribute this. This would give me x squared minus 3x minus x plus 3 all over the LCD. Now here we can combine these two like terms. Negative 3x minus x is negative 4x. And now I can distribute this negative, which would give me 4x plus 8 minus x squared plus 4x minus 3 all over the LCD, which is 4 times x plus 3 times x minus 3. Combine like terms in the numerator, and we get negative x squared. 4x plus 4x is plus 8x. And then 8 minus 3 is plus 5. All over 4 times x plus 3 times x minus 3. And this would be my final answer. So again, just to remind you, for the denominators, you don't have to actually multiply. You can just leave it as the LCD that you have written. But for the numerator, you want to distribute everything and then combine like terms, making sure that the numerator is written in standard form, which just basically means from the highest exponent to the lowest exponent. And that's adding and subtracting rational functions.